Welcome to video 7 for this unit on functions. In this video, we're going to focus on inverse functions. Sometimes it is useful to reverse a function so that the original output is now the input. Suppose Han lives 400 meters from school and walks to school. D equals 400 minus W gives Han's distance to school, D, in meters, after he has walked W meters from home. With this equation, if we know how far Han has walked from home, W, we can easily find his remaining distance to school, D. Here, W is the input, and D is the output. What if we know Han's remaining distance to school and want to know how far he has walked? We can find out by solving for W. W equals 400 minus D. With this equation, we can easily find how far Han has walked from home if we know his remaining distance to school. Here, W and D have switched roles. W is now the output and D the input. The equation W equals 400 minus D represents the inverse function of the original function. An inverse function reverses the input-output pairs. For example, the initial function could take 100 as an input and give 300 as an output. The inverse function could take 300 as an input and give 100 as an output. It is helpful to interpret the inverse of a function in terms of a situation and the quantities it represents. Suppose a linear function gives the dollar cost C of renting some equipment for n hours. The function is defined by this equation: C equals 8.25n plus 30. If we know the number of hours of rental, n, we can substitute it into the expression and evaluate it to find the cost, C. What is the inverse of this function, and what does it tell us about the length and cost of rental? To find the inverse, let's solve for n. N equals the quantity C minus 30 divided by 8.25. If we know the cost of rental, C, we can substitute it into the expression, the quantity C minus 30 divided by 8.25, and evaluate it to find the hours of rental, N. Notice that the equation defining the inverse function is found by reversing the process that defines the original linear function. The original rule tells us to multiply the input, n, by 8.25, then add 30 to the result to get the output, C. The rule of the inverse function shows that we subtract 30 from the input, C, then divide the result by 8.25 to get the output, n. Let's look at another situation. The water in a rain barrel is being drained to water a garden. Function V gives the volume of water remaining in the barrel in gallons t minutes after it started being drained. This equation represents the function v of t equals 60 minus 2.25t. From the equation and description, we can reason that there were 60 gallons of water in the rain barrel and that it was being drained at a constant rate of 2.25 gallons per minute. This equation helps us find the output, v of t, when we know the input, t. Suppose we want to know how long it would take before the barrel has 20 gallons of water remaining, or how long it would take to empty the barrel. Let's find the inverse of function v so that the volume of water is the input and time is the output. Even though the equation is in function notation, we can still solve for t. This equation now shows t as the output and v of t as the input. We can easily find or estimate the time when the barrel will have 20 gallons remaining by substituting 20 for v of t. We can also find the time when the barrel is empty by substituting 0 for v of t. Thank you for watching video 7 of 7 for this unit on functions.